Hey, let's talk some more scientific notation. This week we are continuing learning about what scientific notation is used for, how it's helpful, and we're going to extend our knowledge of scientific notation into actually computing operations, add, subtract, multiply, and divide with numbers in scientific notation. So one thing I want to make sure you're really clear on, the definition of scientific notation is a number between 1 and 10 multiplied by a power of 10. And Ms. Johnson really worked on that a lot with you guys last week, and hopefully you're feeling really good about that. I want to make sure you understand why powers of 10, and just to reiterate that that is all about place value. Our number system works on a base 10 system. When your numbers get really big, you're just moving farther in the tens, hundreds, thousands, 10,000s, 100,000s, and on and on and on, up to billions and millions. And then even beyond that, we don't have names for, the scientists often have to use. They work with really, really big numbers. But that's all about place value. That power of 10 is a shorthand version of telling you the place value. Likewise, when you get really, really small place values, tenths and hundredths and thousands and 10,000s, and get smaller and smaller and smaller and smaller, you get really, really small place value, again, using powers of 10 with a negative exponent. So having an understanding of the fact that that power of 10 is just showing you place value can help you get more efficient at this mathematics this week. So with that in mind, we are going to move into page 20. So make sure you get page 20 out in front of you. It's all about multiplying and dividing in scientific notation. Page 20 in front of you, pen or pencil in hand, and here we go. Page 20 starts by talking to you about Yellowstone National Park. It is the 8th largest national park in the US. And in case you didn't know this, just out of curiosity, the 7 before that, 6 of those are in Alaska. So lots of big national parks in Alaska. And number 5 on the list is in California, it's Death Valley. So after those in Alaska, Death Valley, number 8, 8th largest national park in the US is Yellowstone. This map here, the nice thing about showing you here in my smart file, the one on your paper is all black and white. Here it is in color, just if you want to see what it looks like a little better. There's a scale over here. This shows you a zoomed in view of Yellowstone National Park, and this little map over here shows you where in the US Yellowstone is located. It's right here in the corner between Idaho, Montana, and Wyoming. Yellowstone National Park. If you take a look at that, if I asked you what shape that national park is, just in general, you'd probably tell me it's approximately a rectangle. Right? And I would agree with that. It's approximately a rectangle. So with that in mind, let's look at these questions here. Yellowstone, looking back up at question number 1. Yellowstone runs about 3.343 times 10 to the 5th feet north to south. Hey, look at that, given to us in scientific notation, which makes sense because that's what we're working with right now. And about 2.9 times 10 to the 5th feet east to west. North to south is this direction. East to west is across the bottom there. So what are they doing here? They're giving me the length and the width of this rectangle, the base and the height of this rectangle. So I'm supposed to calculate the area. Does anything come to mind if I ask you about area of a rectangle? Oh yeah, length times width. And if you look at context clues here, these notes are called multiplying and dividing in scientific notation, so chances are I'm going to have to multiply and divide, and I absolutely am. So what is the approximate area of Yellowstone National Park? Express your answer in scientific notation. I'm going to show you my setup here, and you're going to see the answer, and I want you to just take a second, let your brain process it while you write it all down. This is a multiplication problem because it's area. So I set up my multiplication problem right here. 3.343 times 10 to the 5th. And I put that part in parentheses because I got a times here and a times here and a times here. And it's just all those multiplications are a little confusing. So I put parentheses around it to keep that more clear. And then I've got 2.9 times 10 to the 5th. Okay, multiply those two. So make sure you take a second and write down on your paper the multiplication setup there. Now, let me take your mind back to what we did with exponents to show you the connection here, because really what we're about to do is the same as what we did with exponents. Here's what I mean. I'm going to write it over here. If you want to put it in the margins, you have some margins on your paper. I don't have the margins on my file here. But what I'm talking about, or you could write it way up on the top, I'm going to try and squeeze it in on the top here. If I did a problem like this, you see what I'm writing on the top? 5x squared times 2x to the third. I said this quite a few times when we were working with this, but I'm going to say it quite a few times more. What do I do here? I multiply the coefficients. That is 5 times 2. Multiply the coefficients. Add the exponents. What did I do? Multiplied the coefficients, added the exponents. Guess what? That is precisely what I did on problem number 1 over here. I multiplied the coefficients. Whoa. Multiplied the coefficients. Go ahead, grab your calculator right now. See, get the actual feel of typing this in here so you know, so your brain really processes what did Miss McGowan did. Oh, she typed in her calculator. Ready? Do this with me. 3.343 times 2.9. Multiplied the coefficients. And that's precisely where I got that 9.6947 number. That is coming from, right here, is multiply the coefficients. And then guess what I did? I added the exponents because those bases are the same. As Ms. Johnson reminded you last week, with scientific notation, those bases will always be tens because it's a number between 1 and 10 times by a power of 10, multiplied by a power of 10. So we will be able to add those exponents. Multiplication in scientific notation. That's it. Multiply the coefficients, add the exponents. I mean, that's almost it. Sometimes there's a little bit more. So this right here, and I kind of covered up that 10, so I want you to be able to see it. This right here, 9.6947 times 10 to the 10th square feet, that is the approximate area of Yellowstone National Park in feet. Now, in square feet, square footage, because remember, area is the square space. Now, another way that we measure land is with acres. So question number 2 says 1 acre is equal to 4.356 times 10 to the 4th square feet. They want me to combine my answer with problem number 1 to this new information in problem number 2 and figure out, okay, if Yellowstone is this many square feet, how many acres is it? Well, again, let's use our context clues. Look back up at the title of this page. What is it about? Oh, multiplying and dividing. So our problem number 1 gave us an example about multiplying them. Problem number 2 is an example about dividing them. So if I know how many square feet it is, and I know that it is this many, 4.356 times 10 to the 4th square feet per acre, this is a division problem. I'm going to take the square feet that I know, and I'm going to divide it by the square feet that go in an acre. And where did this answer in this box come from? Well, guess what I did? This time, I divided those coefficients. Why? Because it's a division problem. So go ahead, type in your calculator. You might even have the 9.6947 still sitting there. And you can go divided by 4.356. Whoa, that's a big long decimal. So what did I do? I rounded it. You can look at what's on your calculator and look at what I rounded it to. And see if you can understand why I rounded it the way that I did. Where did the exponents come from? Well, I divided coefficients and I subtracted the exponents. 10 minus 4 is 6. So it is 9.6947 times 10 to the 10th square feet approximately, which is equivalent to 2.226 times 10 to the 6th acres. These powers of 10 are place values. It's really just a way for us to write the place value without having to keep track of all of those zeros. I absolutely could have done this division in standard form, but I would have a lot of zeros, a lot of place values to keep track of, to type in my calculator. Putting it in scientific notation means I really just have to deal with the decimal coefficients, and the exponents keep track of the place values for me. Let's practice this some more. So these instructions say find each product, that means multiplication, or quotient, that means division. All of your work today and all of your practice today is all about multiplying and dividing in scientific notation, okay? So if you take a look at number 3, this is a division problem. I want you right now to type in your calculator 2.3958 divided by 1.98. You are dividing coefficients. Go ahead, type it in your calculator, practice it. 2.3958 divided by 1.98. You're going to divide coefficients and you're going to subtract exponents. Now, always make sure you subtract them in order. because you need to know if this answer comes out as a really large number with a positive exponent or a really small number with a negative exponent. So you divide coefficients, you subtract the exponents, and this is the answer you should get. Take a look at that on number 3. You type those in, divide the coefficients, you should get 1.21. 3 minus 7 is -4. Now we got used to with our last exponent stuff, we always said never leave a negative exponent in your answer. Well, guess what? With scientific notation, scientists do it all the time, so it's completely accepted notation to leave that negative exponent. But remember, it just represents a place value. So if you changed it to a fraction 1 over 10 to the 4th, that's still showing you the place value. 10 to the -4 means the 10,000ths place. So 1 over 10 to the 4 is still 10,000ths, just fraction versus decimal form. But in scientific notation, you can leave the negative exponents. It means really small number. All right, come over to number 4 with me. This is a multiplication problem. So first, you're going to multiply the coefficients. That is 7 times 3.5. Go ahead, grab your calculator, type it in, 7 times 3.5. And then you're going to add the exponents, 5 plus -3. And a lot of you write that down and go, yeah, I feel good about that. Moving on. Wait, stop. Are you really done? Let's all put a note off to the side. See over here, questions and notes. You are going to write right there something really important that I want you to remember. Ms. Johnson worked on this with you last week. You always need to check. Make sure your answer is in scientific notation. Number 1, or number 3 actually. Number 3, is it scientific notation? Yes, it is. Number 4, is it scientific notation? No, it's not. How come? Because 24.5 is not between 1 and 10. So I want to show you something a little bit different, something you can use. If you have it in your brain that those powers of 10 are just about place value, it's all about place value. What you're doing when you move the decimal is you are shifting the place value. So if you move the decimal and shift the place value, you have to balance that by also moving the exponent, because decimal means place value, exponent means place value. Now let's come back over here. See this note on the side where you said make sure your answer's in scientific notation? We are going to add a couple notes to ourselves, okay? This is a handy little trick that you can use when you're trying to fix something that is almost scientific notation, but not quite. If you move, I'm going to draw an arrow this way, and I'm going to write decimal, DEC for decimal. If you move the decimal to the left, is that 24.5 is going to turn into 2.45. Which number did I get, when I went from red to blue, did I get bigger or smaller? Place value wise, I went smaller, right? This number is smaller. So when you move the decimal to the left, your place value gets smaller. So you have to balance that by moving the exponent up. This is all a balancing act because this red number is supposed to be equivalent to the blue one I'm about to write. They're not supposed to be different numbers. I'm just adjusting it so that it's officially in scientific notation. So I move the decimal to the left once, which means I need to move the exponent up 1. And that's just a shorthand version for, you can totally, if that just completely confused you, this is what you did last week. You went, okay, 24, no, just kidding, I'm gonna not write that. You went 2.45, and because you moved that once, you went times 10 to the 1, and then you brought the 10 to the 2 down, and then you used product of powers and added those exponents together. That way works perfectly. This way also works perfectly if you think through, this way being the blue way, if you think through, if I move the decimal, if I move the place value smaller, I gotta adjust that. It's a balancing act. If I move the decimal smaller, the exponent's gotta get bigger. Now, in the opposite end of things, we're also gonna write this. This means if I move this way with the decimal, sometimes you have to adjust that. That is gonna actually make the place value bigger, and then you have to adjust it by making the exponent smaller. It is a balancing act. And I'll show you what I mean as we keep practicing these. All right, let's look at number 5. Number 5, I am going to multiply coefficients. And this second value here in the parentheses is like all coefficients because there's no power of 10. That's okay. Grab your calculator right now and type in 3.1 times 562.1. I got, so you're looking at this on your calculator, hopefully you got the same thing. I got 1,742.51. And I still just have times 10 to the negative 3. Now I have to adjust this, so let's practice our new. You can keep these notes out right here over here showing you like if the decimal moves this way, the exponent moves this way, but just remember it's opposites because you're trying to balance out the place value. The decimal is the place value, but so is the power of 10. So I need the decimal to move 3 places to the left so that I get 1.7, and I could round this if I wanted, but I'm just gonna write it all. If I move the decimal 3 to the left, the exponent goes 3 up. Think the number line. If you're at negative 3 and you go up 3, oh, you're at 0. That's fine. That is officially scientific notation. Okay. All right, number 6, division problem. So I'm going to, actually I'm going to let you guys divide the coefficients. Type it in your calculator. Go ahead, divide those coefficients. 3.006 divided by 7.3. Did you see this big long decimal? Watch what I'm going to do. I'm going to round it. It doesn't tell me what I'm supposed to round it to, so I'm just going to decide on 3 decimal places. 0.412. Look at your calculator. Can you tell why I rounded that to a 2? Make sure you understand rounding. So divide the coefficients, subtract the exponents. Divide coefficients, subtract exponents. Are we done? No, this number is too small. This is not between 1 and 10. This time I need to move the decimal once to the right so that I make 4.12. Because I just made from red to blue, I made the blue number bigger. Now the exponent needs to go smaller. I only moved the decimal once, so move the exponent down 1. And now we're in scientific notation. All right, the other thing you have to do with multiplying and dividing is you have to get, you have to do some word problems. You have to be, that's the whole point, right? If you're using scientific notation in real life, your problems are not gonna just be, you're not gonna do a whole sheet of just, here's some scientific notation, calculate it. It's gonna be some kind of problem that needs to be solved or a question that needs to be answered that involves really large or really small numbers, which is what scientific notation is for. So let's try some of these and let's challenge ourselves by working with them in scientific notation. Yes, some of these would totally be solvable without it, but we're going to challenge ourselves by using scientific notation. All right, look at this. In the world, so you should be flipping your paper over now to page 21. That's where these things are. Or you have to go to the next page, but it's the continuation. Keep going in your math binder, page 21. In the world, approximately 1,146,000,000 people speak Chinese as their first language, while 341 million people speak English as their first language. Okay, I want you to underline this right now. Approximately how many times more people speak Chinese than English as their first language? The challenge in these questions is just deciding, should I multiply or should I divide? And you know what happens to people on this problem? They read that and they see the word times and they go, times, I'm multiplying. Pause for a minute though. Does that really make sense? If this is asking me how many times more, that means the multiplication has already happened and I'm trying to work my way backwards out of it. So here's a tip that I want you to write over here. If you see that phrase, how many times more, it's a division problem because you're working backwards. It is a division problem. Don't be fooled by seeing the word times in it. Think through it and think what makes sense. This is a division problem. Here's the other tricky thing about this problem is you have to actually change these values into scientific notation because that's, look at the instructions right here. Use scientific notation to answer each question. So I'm going to show you the setup. I'm going to show you the answer on these ones, okay? This is a division problem. You ready? Look what I did. Right here. This is 1.146 times 10 to the 9th. Where did that come from? That came from changing this number into scientific notation. And then I took this one and changed it into scientific notation right there. 3.41 times 10 to the 8th. Then what did I do? It's a division problem. Make sure you're taking the time to write all of this down. You guys know when you take your pictures of your notes and submit them to your math teacher, they're looking for, did you write everything down? Okay, I'm going to divide coefficients. Go ahead, type it in your calculator. 1.146 divided by 3.41. And that's where that number came from. Dividing coefficients. Then what did I do? I subtracted exponents. And that's where that number comes from. Say it again. Divide coefficients, subtract exponents. You can even whisper it to yourself right now. Divide coefficients, subtract exponents. Then I took a look at this and I went, that's not in scientific notation. And also, let's think about what makes sense in this problem, about approximately how many times more. Well, if I move this over, then I move this down, right? Bigger, smaller. Catch that? Bigger, smaller. And that makes 10 to the 0. So that came to 3.4 times 10 to the 0. 10 to the 0 is 1. Oh, that's 3.4 times more. 3.4 times more people speak Chinese than English in our world. Chinese would be a very valuable language to learn. All right, number 8. The thickness of a dollar bill is 0.010922. Okay, question number 7 was all about really large numbers. Question number 8 is all about really small numbers. So how many times, okay, the thickness of a dime is 0.135. How many times, oh, there it is. How many times thicker? This is a division problem. Okay, I'm gonna help you out on this one. You ready? You ready to see it? Be ready to watch and listen and write this all down. First thing I did is I changed this really small number into scientific notation. Make sure you write that down. Then, oh, just kidding, that one's on the bottom because it's smaller. How many times, look at the wording on this. How many times thicker is a dime compared to a dollar bill? So I put dime on top, dollar bill on the bottom. Likewise, back on question number 7, it says, how many times more people speak Chinese than English? So that phrasing there also tells me what order to put this in. Chinese over English, dime over dollar bill. Okay? So I changed them to scientific notation. They're really small. That's why I have negative exponents. Then what did I do? I divided these coefficients. I typed in my calculator 1.35 divided by 1.0922. And that's where that came from. A lot of people look at this and go, wait, Ms. McGowan, where did you get 1? Okay, take your brain back to 7th grade. I really did subtract these exponents. But watch, you can write this down for yourself. You are subtracting, but you're subtracting a negative. Your pen just got really slow there and it confused me. You're subtracting a negative. Do you remember from 7th grade when you subtract a negative, you are actually adding a positive. So really, -1 minus -2 is -1 plus 2, which is where I got 1. And then I figured, I mean, that's scientific notation. It is. This right here is scientific notation. But I figured maybe this answer in the box makes a little more sense. It's 12.4 times thicker. Okay, here's what I'm going to do on 9 and 10. I'm going to read them to you, and I'm going to help you know if you should multiply or divide. And then I'm going to let you guys try them, because that's the trickiest part on word problems. Do you multiply or do you divide? And then once you know that, you set it up and you either multiply coefficients and add exponents, or you divide coefficients and subtract exponents. Okay, so question number 9 says, there are about 6.022 times 10 to the 23rd atoms of hydrogen in a mole of hydrogen. This is another way of saying per atoms per mole. Okay, so if they're telling me it's this many atoms per mole, and it says how many hydrogen atoms are in this many moles, I'm going to tell you right now, this is a multiplication problem. So in just a second, you'll set that up. But number 9 is a multiplication problem. Number 10, a cable company earned $125 million in 1 year. The next year, they earned $312.5 million. Estimate how many times bigger their profit was the second year compared to the first year. How many times bigger? This is a division problem. It's also tricky because you have to change those ones to scientific notation. So now that you know number 9 is multiply and number 10 is divide, you guys are going to try those 2 problems. Pause me, let me wait here, and you try them. All right, let's see how we did. Number 9, multiplication problem. Here we go. I set up multiplication right here. 6.022 times 10 to the 23rd times 3.5 times 10 to the third. So listen to this vocabulary again. What did I do? I multiplied coefficients. I multiplied coefficients. 6.022 times 3.5 gave me that number. I multiplied coefficients and I added exponents. I multiplied coefficients and I added exponents. Multiplication, scientific notation, I'm going to say it one more time. Multiply the coefficients, add the exponents. Then I went, hey, that answer's not quite scientific notation. So you can see right here, if I move to the left, that makes it smaller. Therefore, I have to make this bigger. I move that once, bigger by 1, and led to the answer 2.1077 times 10 to the 27th hydrogen atoms. This precisely models what we have scientific notation for. I don't even know a name for that place value, but it has too many zeros for me to keep track of. So, scientific notation. That was a multiplication problem. Number 10, check this out. Did you change them to scientific notation correctly? And it said how many times bigger was their profit the second year? So I put the second year on the top divided by the first year. And I changed them to scientific notation. 3.125 times 10 to the 8th is what that would be in millions. 1.25 times 10 to the 8th. So I changed them to scientific notation. And then, guess what I did? I divided the coefficients. I divided the coefficients and I subtracted the exponents. Divide the coefficients, subtracted the exponents, you had a 2.5 times bigger profit. Now I'm going to tell you right now the practice you're going to do after this, you're going to do one more example with me here, just as an extra challenge to see how we use scientific notation. But I will tell you, if it helps ease your mind a little bit, the practice you're going to do after this doesn't actually have any word problems yet. We're going to practice those a ton on Wednesday. But it is all multiplying and dividing. So what you have to keep in mind is multiplication. Multiply the coefficients and add the exponents. For division, divide the coefficients and subtract the exponents. But before you get to that practice, one more problem. And I've started setting it up, but let me read it to you. Brazil has an area of approximately 8.51 times 10 to the 6th square kilometers and a population of about 1.99 times 10 to the 8th people. So this is their land area, and this is how many people live there, okay? Where Portugal has an area of this, that's their land area, and this is their population, the number of people. On average, which country has a greater number of people per square kilometer? Does that language sound familiar to you? Do you remember doing a bunch of unit rates in 7th grade? If it said dollars per hour, you'd divide dollars by hours. If it said miles per minute, you'd divide miles by minute. So if it says people per square kilometer, look what I did. I set up division problems. People divided by land. And I did the same for Portugal. People divided by land. Two calculations here, one for Brazil and one for Portugal. These are division problems. I'll give you a second to set those up. You can pause it if you need to get those written down. But then what did I do? I divided coefficients. Look at Brazil. I divided coefficients. I did 1.99 divided by 8.51, and I subtracted exponents. And that led me to that. Did the same thing for Portugal. Divided coefficients. Always do the top divided by the bottom. Always. 1.08 divided by 9.21, and I subtracted exponents. Okay? And then I went, hey, those are not in scientific notation. That's okay. I can fix that. If this goes this way, one bigger, this goes one smaller. One bigger, one smaller. And actually, I think I took these all the way to standard form, but that's how you'd make it scientific notation. Let's see what I got here. Yeah, I actually times by 10 squared. I typed it in the calculator because I thought it would make more sense that way. And because I'm in America, and that's what my brain wants to do. But the rest of the world, I accidentally did miles. But the rest of the world uses what makes a lot more sense, which is the metric system. These are, of course, square kilometers, not square miles. But this makes it very clear. 23 people per square mile versus 117 people per square mile. Portugal has a greater number of people per square kilometer. I said miles again, per square kilometer. All right, so you are going to practice tonight just multiplying and dividing scientific notation. And remember, I'll say it one more time, multiply coefficients and add exponents, or divide coefficients and subtract exponents.